Welcome to differential rate equation explanation for sample exercise. Okay, so let us look at how to solve the problem involving differential rate equation. Okay, so equation is given, okay, then asked to determine the rate of disappearance of hydrogen iodide when the rate of reaction is given. Okay, so when we look at the word terms rate of disappearance, first of all, I will write down negative d Hi, the concentration over time. Okay, then rate. Rate of reaction means I just need to write the word rate. So these are the information given. Okay, so in order to find the rate of disappearance, first I will start off with differential rate equation. Okay, remember when we want to write differential rate equation, write down the word rate first. Okay, after that we start with reactant. Okay, the reactant we have hydrogen iodide. Okay, but hydrogen iodide is reactant, so we must put negative. Okay, then after that we will go to product. Okay, product we have hydrogen and iodide. And remember, hydrogen and iodide are product, so it is formed, so we put positive. Okay, now we go back to hydrogen iodide. Okay, the coefficient is 2, so when we put in the rate differential equation, it is not times 2, it is 1 over 2. Okay, thus, when we look at this equation, means that the rate is equals to hydrogen iodide rate of not rate of disappearance yet, okay, because the rate of disappearance we have to write in terms of negative, okay, where we don't have the coefficient. Okay, but from the differential rate equation we know that the rate information is given. Then the next one is we can find rate of disappearance of Hi. Okay, so remember, in order to get the rate of disappearance of hydrogen iodide, we need to multiply by 2. And don't forget to write the units. Okay, now next question is also determine the rate of disappearance of hydrogen iodide. Okay, so when we look at this term, automatically we write down negative because it is disappearance, means it's referring to reactant, so negative DHIDT. Okay, when rate of formation is given, rate of formation of iodine means that it's positive the iodine over time, the rate of formation of iodine. Okay, again, same thing, we always start with differential rate equation. Okay, so what we going to relate is hydrogen iodide and iodine. Okay, so these two we get it from the differential rate equation. Okay, then after that, remember, rate of disappearance, the rate must not contain any coefficient. Okay, so what we do is 2, we bring it up here. Okay, and then we will find the final answer with the unit. Okay, and don't forget, usually student will left out the negative sign. Must include because this one show it is the disappearance negative. Okay, so one more time I want to highlight, when we talk about rate, there must be no coefficient. Okay, like here, there is no coefficient when we write rate. Okay, so that's all for differential rate equation.